Hey, in this tutorial I will show you how to set up a shader that will allow you to create this effect purely in Blender. Also, I want to give a shout out to Oliver Loftus, whose blog on ArtStation actually inspired me to do this. This tutorial may be a little on a long side, but I encourage you to follow along and I hope that you will get something out of it. If you don't feel like it, you can also get the blend file from my gumroad for free. Link in the description. Of course, if you can afford to support me by paying for it, then it's even better, but no pressure. Most importantly, if you either follow along or get the graph from my gumroad and make something out of it, please share with me on my Instagram or Twitter. I would really love to see if I make any impact. Hope you enjoy and let's get to it. So let's jump into Blender, select everything and delete because we don't need that, and go into Edit Preferences and make sure that the Node Wrangler is enabled in your add-ons. Now we can create a plane. That will be our portal. And let's jump into the Shading tab. Let's also turn down the world opacity so that we can see everything better. Now with our plane selected, let's click New and we can delete the principled BSDF. Now we will need few nodes, so let's start with adding a texture coordinate as well as the geometry node. Now we will also need a mapping node. And the geometry output that we will use is the incoming. In order to preview that, you have to hold down Ctrl, Shift, and use the left mouse button click on the node. And that lets you basically preview the output. And the incoming output is basically a vector based on where you view the object from. But because our plane is two-dimensional, there is no thickness to it, we can only use the X and Y values to control and simulate the depth of our shader. So in order to do that, we will need few nodes. Let's start with vector math. Let's change it from add to divide. And also let's add a separate XYZ and connect incoming to that. And now using the vector math node, let's divide the incoming by the Z value and connect that to the mapping location. And the vector, let's use the texture coordinates object. Now, if you preview the mapping, you don't really see the depth. And that is because we need to control this using another vector math node. So let's copy over this one. Change it from divide to multiply, and let's add a value input and connect this to the other socket. And now, as you can see, if you change this value, if you go down, you see that the texture coordinates are being offset by the amount that you have in this, by the amount that you basically have here. That is basically almost done, except for one more thing. We need to also get rid of the Z value from our output vector, because we don't need that and that may cause some issues later on. So in order to do that, we need another separate XYZ node connected with this mapping and also combine XYZ. And here basically connect X to X, Y to Y, and leave the Z as 0. As last touch, we can also add another vector math. Let's change it to multiply. And this will basically control the scale of our patterns that we will add later. Let's copy the value node, put it in here. Let's set it to 1. And as you can see, when you change it, then the scale of the texture coordinates changes. If you plug actual, let's say, noise texture, then you see that this value is basically responsible for the scale, and this one is the offset. If you look from the side, it's better visible, so that it's going up and down. And that is basically the very foundation of our shader. So in order to clean this up a little bit and not have it so messy, we can promote this into a group. So let's also add in the geometry into the group. Then select all the nodes up to the last vector map. We can delete the noise texture for now. Let's select all the nodes and simply click Ctrl G. That will create a group. And you also have those 3 vectors as inputs, but because they're all named vector, you don't really know which one is which. So let's name them. So the first one on the bottom goes into the first multiply, and this is what controls the height offset basically. But we don't really need 3 value vector for it. We want just one number to control how low it will fall into basically how low it will appear. So in order to cheat this a little bit, you can add a temporary math node and just drag from this empty to this gray socket, and then you can delete the math node, and you can see that it created this gray socket in the input, in the group input. Then simply take it and drag it over to this vector, and that basically will apply whatever value is here into all 3 values of the vector. Let's also name it appropriately. So this will be our height offset. Good, and now the middle vector is empty, so we can just simply click on it and this minus button to delete it. And let's also put this height offset on top using this arrow. Now the next thing is our mapping. Whatever goes into mapping is basically our input vector. So we can just call it that. It is the second vector, yep. So let's just call it input vector. Now the last one is what controls our scale. So we also need just a single number value. So we can do the same trick. Just bring a math node, drag in from empty to the gray socket, then delete the math node, and simply you can drag in this last vector using holding down Control and left mouse button, drag it to the gray one, and you can name it appropriately. So in this case, scale. And this empty vector we can just delete because we don't need that anymore. Alright, and in the group output, we simply drag in the last multiply vector output. And we can also call it output vector. And now this node group is basically what controls our parallax effect. So let's name it accordingly. Control C, Control V. And here, as you can see, again, holding Control, Shift, left mouse button, you can preview how it looks like, and using the height offset you can lower it, and using the scale you can adjust the scale. Let's leave it at 1 and height offset at, let's say, minus 0.5. And we can delete those nodes because we don't need them anymore. You can already use that to offset your textures in the fake depth. As you can see, it works quite well. Yeah, so basically that's it for the parallax effect. Next, let's create the pattern. In order to do that, let's start with a wave texture and a gradient texture. Now we can hook up both of those with our parallax. Let's check it out. So the gradient texture, let's change from linear to sphere. Spherical, yep. And let's also bring the offset a little bit higher, because now it's a bit too low. Can't really see anything. Minus 0.5 sounds nice. Now using math node, let's change it from add to compare. Let's create a mask for our wave texture. Simply just change the value of the epsilon to make it thicker or thinner, and the value to make it bigger or smaller. but don't go too much because then it clips out when you reach the border of the gradient texture basically. So keep it modest, maybe something like this. Yeah, this looks fine. And now let's use another math node. This time it's gonna be a multiply, so that we will multiply our mask with our wave texture. So basically whatever is within this white, within this white area is gonna pop out, and whatever is black is gonna be cut out. So right now we have those lines, we can change it in the wave texture, change it from bands to rings, and the axis from X to Z. Now as you can see we have this, this nice ring, but we don't really need that black lines in between. We only need basically the white part and maybe a little bit of that fall off into the gray. So we can adjust that here with the scale. Something like that. Yeah, this works fine. And now in order to make it a little bit more interesting, we can also add some distortion to it. So first, let's hold down the shift and using right mouse button, click and drag to go through the links in order to create this reroute link that you can control hitting G and just moving it around. It just makes it easier. Now we can simply add mix RGB, change it from mix to linear light, and add a noise texture and plug it into the second color input. Now you can adjust the scale of the noise as well as the strength with which it's gonna affect the ring. And let's make this fairly low frequency detail. So like a first step. And then copy and paste again, so that we can add a high frequency detail with the same setup simply by changing the scale. And also let's change the noise texture type from 3D to 4D, just so that later we can manipulate this W value to animate both the big shape as well as this high frequency details on the sides. As you can see now, the noise appears to be on the surface and you're looking through it onto the ring below, and it is because the vector now is not connected, so we need to do that as well. Simply connect it from the parallax group node to both of the noise textures, and now it gets a bit messy, so let's just adjust the scale again. Maybe something like this. Yep, that seems fine. You see a little bit of that black ridge here. So let's go back to the wave texture and fix that. You can do it either by adjusting the scale or just playing around with the offset. Yep, this sounds fine. Let's also change the noise here so that we don't have this hole in here. Yep, that seems alright. Maybe also the factor of this high frequency noise. Alright, we can also test this already. So you can just type in hashtag frame and divide it by, let's say, 50. This basically is gonna change the value every frame. Let's also pull out the timeline. And we can already hit play. You can see that it wobbles slightly. And if we do the same in the high frequency detail, divided by, let's say, 120, then you see that independently it moves as well. Yeah, that seems alright. Maybe a little bit here. Okay, so this basically concludes our pattern. So you can simply select all the nodes and click Ctrl G to group it again. And here you see again we have the 3 inputs, but in this case it's all the same vector. So you can simply delete the color, one of the vectors as well, and then connect this one input vector that left into all the 3 sockets, 2 noise textures and 1 linear light. Now in order to tidy it up again, we can create another reroute. So again, holding shift and then using left mouse button, click and drag through the links that you want to join, and just bring it a bit down. It just helps with the readability. Alright. And let's also name it appropriately. So the group input, the group output is a pattern, black, white. And the group input is basically the input vector. And now, we have some issue here. Let me check. Oh yeah, the group input should not be connected to factor of the first linear light, but rather the color 1. Yeah. Now we can just leave the group. Let's put it close together. And now we have the parallax and the node group together. The next thing to do is basically just copy and paste this group setup in order to have more, let's say, dimensions to our depth. So here, let's connect the texture coordinate object into the input vector of the parallax. And let's adjust the height offset. So let's keep the first one at 0.5, next one at -1, another one -1.5, and the last one, let's say -2. Now let's also join all of the patterns using mix RGB nodes and change it from mix to lighten, and also crank up the factor all the way up. Let's connect this one as well, join them all together. And now let's preview the last lighten node. Yep, this is it, that's our pattern. Now the issue is that all of those rings basically look the same, have the same noise and the same animation as well, which doesn't really look appealing. But there is an easy fix for that. We simply need to edit the node group that's responsible for pattern. Let's also name it, by the way. Pattern. So let's go inside using this button. And now in order to add an offset, we'll just need to add a mapping node right here before the 2 noise textures where they are getting connected. And in the group input, we will need to create another variable. So let's use our trick with the math node. Let's just drag it in to make it gray. We can now delete the math node and plug it into the location, because it's just an offset, so we don't really care about the X, Y, and Z value. We just want it to be offset by whatever. So let's also call it appropriately. So it is a noise offset. All right. Now let's also change the name of the other groups as well. Yep. Another one. By the way, if you just paste the same name that is used somewhere else, Blender will automatically just add 001, 002, so that the names are not the same. The label can be, but the name of the group cannot. Alright. Now, as you can see, we have this another variable, and then if you change it, it only affects this one pattern that it's responsible for. So let's just set it off, something that it's different. Okay, now if we click play, then we can see that they're all wobbling, but at a different offset. Okay, now let's make some adjustments so that the further the ring is, the darker it becomes. I think it will give a nice effect once we have the portal set up. And it's not that hard to achieve, so simply just go to one of the pattern groups. And here, let's create a map range node. And basically what we will need is a position of the ring that's closest to the surface, as well as the one that's furthest, so that we can calculate it proportionally. So that if you add more rings, then the gradient from the lightest to the darkest will still work. And we can just connect from group input empty socket into the from min, and that and also from max. Now let's name it as well. From min will be the furthest offset in our sequence, and from max will be the closest. Basically, because closest means it's a from max is basically the biggest number, and it is closest to the surface because they are going down into the negative, basically. And also value. Value is gonna be the individual value of the single ring, and that is basically its own height offset. So let's name it like that. And let's drag it all the way back, so that at the very end, let's add a math node with multiply. And let's connect the map range as well as the last multiply to it. And the result will go into the output. Now, as you can see, we have more variables here to set up. And the height offset we can actually take from the parallax. So let's just go into the parallax group again. And let's drag from input the height offset into the empty in group output. This will just basically pass through the variable. Now we can simply use the height offset here and connect it here, and fill in the furthest offset and the closest offset. So the closest offset is, in our case, minus 0.5, and the furthest is minus 2. So we need to fill that in. If you guys know any other option where I could just fill in all those numbers automatically, somehow connected all together, then let me know. But so far I didn't find a way for it. Minus 0.5, minus 2, and last one as well. Height offset, minus 0.5, and minus 2. Alright, and now as you can see, we have 1, 2, 3, 4 patterns, but we can only see 3. And it is because in our pattern graph, the map range is set to translate whatever we input, whatever our range is, into 0 and 1. So the last ring here actually has a value of 0, and 0 is basically black. So in order to have it visible a little bit, let's put something smaller, maybe like 0.1, and it's too bright, 0.01, just so we can barely see it. 0.05, that's alright. And the maximum, let's say 1.1, so that it's a bit brighter than it should do. Alright, now let's give it some colors. So let's just go to the last lighten node and add a color ramp. Let's change the color, let's give it some greenish shade. Let's add another one. Maybe like this. Yep. That looks okay. Now we can also add an emission shader. Bring up the strength to 3. and actually connect it to surface, not viewer. And we can also go to the rendering properties and enable bloom, which will give us this nice glowing effect. Okay, so the rings are set up. The next thing that we can do is a background, because right now it's just pitch black. So for that we will need one more parallax. Let's just duplicate that and also connect it to texture coordinate object. Let's put it behind everything so that the lowest one is at -2. So let's just put it at -2.5. Keep the scale 1, that's fine. And let's add a noise texture. Let's connect the output vector to vector. Let's see how it looks like. And let's add a gradient texture. Let's connect the output vector to vector and change it from linear to radial so that we have this effect. And now let's add a noise texture right after that. So this will give us this sort of rays coming from the abyss. And we can also change it from 3D to 4D so that we can adjust this W value to make it move. Let's do it right now. Hashtag frame, again, divided by 80, let's say. Yeah, this looks quite alright. But let's use the factor, so just the black and white values. And let's bring a little bit more contrast using a math node. Sorry, not math node. Mapping range. Map range, yeah. And now, simply by adjusting this from min and from max, we can make the blacks pop out a little bit more, as well as the whites. And this seems alright. And now, in order to make it a little bit more interesting, we can also add some sort of distortion, some noise. So right after the parallax, let's add a mix RGB node. Change it from mix to linear light. And get another noise texture to connect. Color to color. Now this is a little bit too strong. And as you can see, we again have this, this bug that the noise is on the top. So let's connect that parallax vector output with this noise texture as well. And let's move that a little bit out of the way because it's getting crowded in here. Alright. This is way too strong. So let's just turn down the factor here. And maybe scale a little bit, maybe add some distortion. And we can also animate this. Yeah, that seems alright. And now at the end we can add a color ramp. Now, because we went with the greenish theme before, so let's keep it consistent. Let's also choose some green stuff. It doesn't really matter if it's the same shade of green because it's gonna be dimmed down anyway. So just choose something that looks nice. Maybe get another one. And also change the interpolation from linear to constant so that we will have this sort of like hard edges. Yeah, let's pull those a little bit back. Yeah. And let's change this black into something like that. This kind of looks like a watermelon skin, but it's alright. Now let's add a mix RGB to mix together the background with the rings. And you can keep it at mix, and simply by adjusting the factor, you can decide which one pops more. So let's just leave the rings as the main one and bring this up just a little bit. Now connect it to the emission and see how it looks like. Maybe it pops up a little bit too much. It should be just barely visible in the background. Now if we play this animation, that already starts looking like a portal. But what we need now is a mask that will uncover the portal only when we are approaching it with the object. So for that, let's create an empty. Plain axis is fine. And let's also create a transparent BSDF and a mix shader. Now we can connect those two. And for the factor, we need to create a mask that will drive this. So let's go up here and create a texture coordinates, because we will need that as well as mapping. And let's connect the object to vector, but we don't want this texture coordinate be taken from this object, the plane. We want it to be driven by the empty. So simply go to this field, click this eyedrop icon, and then select the empty. So now if you preview the mapping and you select the empty and you start moving it around, you see that it affects the display of the texture on the plane, basically. So yeah, let's go here and let's start making some mask. So for start, let's use a gradient texture. And again, let's change it from linear to spherical or quadratic sphere. The difference is basically in the fall off. But with this selected, if you move the empty in the z-axis, you can see that this already looks like what we needed to do. So we can keep it at quadratic sphere, and let's add it a little bit of distortion. So let's get a noise texture, not white noise, just normal noise, and a mix RGB. Also, let's save the file so that later I can actually share that. Let's call it a portal gumroad, because that's where I will be sharing it. Save. Let's change here the mix to linear light and connect the color. Now this noise texture, let's change it to 4D, and with the gradient texture on preview, we can control how it affects our gradient, and this one we want to be a large scale noise that will be sort of lazy wobbling, and we can later add another layer of high frequency noise to it. So yeah, that seems alright. We can always adjust it later, so let's not spend too much time on it. Frame divided by 50, that's alright. That's quite alright. Let's add another layer of detail. So just copy the linear light, copy the noise texture, and let's just change the factor and the scale of the noise. And also let's add a driver to this. Now if we play this, we can see that there is some stuff going on. Now basically from this gradient texture, we will need to create two masks. One that will be the most outer area, that will basically cut out all the black values to be transparent, and another one smaller that will basically control how much of the inside of the portal we will see. So in order to get that, we will need a math node. Let's change it from add to greater than. Yep. And here this is gonna be our most outer mask, so let's keep the threshold something very low. Let's say 0.01. And then let's copy this math node, plug it again, and this is gonna be our inner mask. So basically where the portal, where you will basically see through into the portal. So let's keep it a little bit higher, maybe something like that. So we can actually already plug the bigger mask into our mix shader that we have right here. Let's organize it a little bit. So this bigger mask into the factor, and now if we enable it and preview, we can see that not much is happening, and that is because we need to go to material properties and enable blend mode, because right now it's set to opaque, but we want to change it into alpha clip, and that will basically clip out our portal. So this already looks like something that could be, I don't know, like a hole on the ground or in the ground. But as a portal, it needs some sort of borders. So to get that, we need another mix shader, mix RGB before it gets to emission. And here the color will be our portal inside and gradient texture. And the factor is basically gonna be our smaller mask coming out of the gradient texture. So let's put it in. Alright, let's keep this here. And now if we preview the mix shader, then we can see that it's actually reversed. Let's reverse those values. Yeah, we can see that we have the border of our portal. If we click play, then it all animates nicely. And if you move this empty object, then it basically moves around. But so far, only the border of the portal gets affected by the empty, and the rings stay stationary. So like if we, for example, move our scale, this plane, then the rings are scaling with it, and that's not really what we want. And there is super easy way to fix it. Simply go to the first texture coordinates that are driving everything, basically. And here in the texture coordinates, choose the object empty, same as we did with the mask. So now, if you move the object, the empty object, then as you can see, the rings inside are moving with it. And that's exactly what we need. Now, another problem is that when we scale the plane, then you see that the noise of the entrance to the portal gets affected. And that is because the noise here does not have a vector connected to it. So let's just take it from the mapping node and connect this into the noise texture as well. Alright, and let's also adjust those values because it seems a little bit hectic. Yeah, and let's also add some colors to it. Color ramp. And because we're going with green, let's also stick to it. And let's change the interpolation from linear to constant, so that it has more of this cartoony look. Yep, this white value. Okay, so basically one more. This is gonna be our inside. It's gonna be the middle, something like this, and the most outer. Something like this maybe. And inside, maybe that. Maybe it's a little bit too bright, so let's bring down the value of those colors. And now if we want to make this border thinner, because right now I think it's too thick, we can simply do that by controlling this mask that fits into the factor of this last mix node. So let's put it like that maybe. And that also requires us to change this color ramp. It's very tight in here. But that looks alright, I think. Now it's on the ground, so let's actually rotate that. So select the plane and the object, and let's rotate it on the y-axis by 90 degrees. And now, as you look inside the portal, you can see that the whole parallax effect is messed up. And that is because we need to make some small adjustments in our parallax group node. And that is transform the input from our geometry node using a vector transform node from world to object space, because right now it is in world space, and that means that no matter how you rotate the object, the vector of the parallax is gonna stay the same. But as soon as you connect this, as soon as you put basically this vector transform in between, then everything seems to be fixed. Yeah. So yeah, just make sure that the orientation of the plane and the object that is driving the texture coordinates have the same orientation, basically. So in the plane case, the z is this way, in the empty case, z is this way as well. That is very important that they are aligned, because as soon as you rotate only one, let's say the plane, then the effect does get a little bit wonky. So just make sure that their orientation is the same. And now if we move the empty, let's move the empty, then you can see that the portal is appearing and disappearing as it goes through. Now, in order to control the size of the portal, let's actually make this plane a little bit bigger, so we have bigger plane ground. In order to control the scale, the size of the portal, you can simply scale the empty on each axis you want, so you can make it more like a capsule. And in order to control the distance at which it opens and closes the portal, simply scale it on this axis. And now the portal will open faster and also stay open for longer while you pass through. And all of this works with the animation, so... And yeah, so that is basically it. That is all there is to it. I hope that you learned something, that this was useful. I know that now the graph may look a little bit scary, but as you were following along, you know which values you can adjust simply to change the effect. So like if you don't like the noises or something, you can just adjust everything to your liking. And I hope that you got some creative ideas on how to implement that in your own project. And if you manage to do something with it, like even following the tutorial, then I would love to see your result. Just would love to see if I actually made some impact. Yeah, and also if you felt lost or stuck somewhere at some point, if my explanation wasn't clear enough or something, then just let me know down in the comments and I will try to answer to the best of my knowledge. So yeah, I guess I'll see you in the next one. Bye bye.